Hi, my name is Romulo Isla Jr., and today we are going to talk about data communication and networking. So, what is data communications and networking? Data communication refers to the transmission of these digital data between two or more computers in a computer network, or data network is a telecommunications network that allows computers to exchange data. Our first topic for today is computer network. A computer network is a set of nodes connected by communication links. A node can be a computer, printer, or any other device capable of sending and receiving data generated by other nodes in the network. There are two types of communication links. First is the wired link, and the other one is wireless link. The best example for a wired link is a cable, and for the wireless link is the air. Examples of nodes: smartphone, tablet, computer, printer, router, and a cellular tower. There are two types of devices: the end devices and intermediary devices. Intermediary devices are those which deliver data, for example, a router that forwards packets and switch that forwards frames. On the other hand, end devices are those which consume data, for example, is a computer or a smartphone. Now let's move on to the next topic. So what is the internet? The internet is a global system of interconnected computer networks that uses the Internet Protocol Suite or TCP/IP to communicate between networks and devices. It is a network of networks that consist of private, public, academic, business, and government networks of local to global scope linked by a broad array of electronic, wireless, and optical networking technology. The Internet carries a vast range of information resources and services, such as interlinked hypertext documents and application of the World Wide Web, electronic mail, telephony, and file sharing. And the next topic will be network models. So what is a network model? A network model is a database model conceived as a flexible way of representing objects and their relationships. Distinguishing feature is that schema, viewed as a graph in which object types are nodes and relationship types are arcs, is not restricted to being hierarchy or a lattice. To better understand the network models, we have here a layered task. We use the concept of layers in our daily life. As an example, let us consider two friends who communicate through postal mail. The process of sending a letter to a friend would be complex if there were no services available from the post office. Starting from the sender, the letter is written, put in an envelope, and dropped in the mailbox. And then, the letter is carried from the mailbox to the post office. Then after that, the letter is delivered to carrier by the post office. Then the parcel is carried from the source to the destination. The letter is delivered from the carrier to the post office. The letter is carried from the post office to the mailbox. The letter is picked up, removed from the envelope, and read by the receiver. Now for the OSI model, established in 1947, the International Standards Organization, or ISO, is a multinational body dedicated to worldwide agreement on international standards. An ISO standard that covers all aspects of network communications is the Open Systems Interconnection or OSI model. It was first introduced in the late 1970s. There are seven layers in the OSI model, and these are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So we have here an example of an interaction between layers in the OSI model. From the sending computer, it goes from application or application layer to presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. The data will be transferred to the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and down to the application layer of the receiving computer. So what does these layers do? The application layer is responsible for providing services to the user. Presentation layer is responsible for translation, compression, and encryption, while the session layer is responsible for dialog control and synchronization. Transport layer is responsible for the delivery of a message from one process to another. The network layer is responsible for the delivery of individual packets from the source host to the destination host. Data link layer is responsible for moving frames from one hop node to the next. Physical layer is responsible for the movements of individual bits from one hop node to the next. TCP/IP protocol suite. The layers in the TCP/IP protocol suite do not exactly match those in the OSI model. The original TCP/IP protocol suite was defined as having four layers: host to network, internet, transport, and application. However, when TCP/IP is compared to OSI, we can say that the TCP/IP protocol suite is made of five layers: physical, data link, network, transport, and application. Four levels of addresses are used in an internet employing the TCP/IP protocols: physical, logical, port, and specific. Now this is the relationship of layers and addresses in TCP/IP. Transmission impairment. Signal travels through transmission media which are not perfect. The imperfection causes signal impairment. This means that the signal at the beginning of the medium is not the same as the signal at the end of the medium. What is sent is not what is received. Three causes of impairment are attenuation, distortion, and noise. Attenuation means loss of energy, which means weaker signal. When signal travels through a medium, it loses energy, overcoming the resistance of the medium. Amplifiers are used to compensate for this loss of energy by amplifying the signal. Distortion means that the signal changes its form or shape. Distortion occurs in composite signals. Each frequency component has its own propagation speed traveling through a medium. The different components therefore arrive with different delays at the receiver. That means that the signal have different phases at the receiver than they did at the source. Noise. There are different types of noise. Thermal. Random noise of electrons in the wire creates an extra signal. Induced. From motors and appliances, devices act as transmitter antenna and medium as receiving antenna. Crosstalk. Same as above but between two wires. Impulse. Spikes that result from power lines, lightning, and etc. And that's all for today's video. Thank you all for watching.